Hi guys, my name is Nimil. My other team members are Piyush, Vinita, and Harshita, who will be introducing themselves after I am done. Okay, so let's get started. We have developed a programming language and named it as ProPy. Pro because we feel our language is professional and is acing all the programming concepts, and the word pi comes from Python. During this entire journey of developing a programming language, each of the team members has passionately contributed to this project's success with great determination. So I'll start by giving a high-level overview of our project. That is, the flow of this entire demonstration will be as follows. I'll be explaining our programming language with all its features and constraints. After that, I'll be explaining lexical analysis, which is the first phase of our compiler and the block diagram of our language. After that, Piyush will be explaining the grammar rules and the parsing techniques, followed by Harshita, who will be explaining the evaluator. And in the end, Vinita will walk you through the installation and demonstration along with sample runs of our project. So let's begin with the language description we have implemented for our language. That is, we have some primitive data types such as integer, boolean, string, which have been implemented in our language. Additionally, we have comparison operators such as equals, greater than, less than, equals to, greater than, equals to, and not equals to. Further, we have mathematical operators such as addition, subtraction, multiplication, division, and loops such as while loop, for loop, and a for in range loop. Now, moving on to the extra features that we have implemented as a part of our programming language. Our language supports operators and features such as equals to, not equals to, greater than, less than or equal to, greater than or equal to, and or and not operator, a do while loop, increment and decrement operators as well, and print can print the output of the Boolean expression. Now moving on to the design of our language, that is the block diagram. So this is the design of our language, and the first stage is an input source file, which is a Python file that will take care of tokenizing. That is, it takes as an input a Python file, and the lexical analyzer breaks the syntaxes into a series of tokens. So after these tokens are generated, we have a parser written in Prolog, which will generate a parse tree. And after that, the evaluator, which is also written in Prolog, will generate output in form of print statements with the help of a Python script. Okay, so that was the design of our programming language. Tools used, we have done tokenizer and parse tree generation using Python, and the evaluation of parse tree is done using Prolog. So we have implemented, so now moving on to the first step of the compilation, that is the lexical analyzer. And we have implemented a tokenizer in Python. It's a very basic script. And now I'll show you guys the code along with how tokens are generated. Okay, so this is our entire Python script. We have implemented our tokenizer in Python. And as you can see, we are taking as an input a ProPy file. And after that, lexical analysis is done by tokens, which results into a list of meaningful tokens. That is, lexical analysis is done character by character wise through the entire file, which generates a list of meaningful tokens. So that's all in this Python file. Now, to have a more meaningful understanding, I'll be giving you demonstration of few of the sample files. That is, as you can see, lexi.py is a Python script, which is going to be generating tokens, and the extension of our language is ProPy. So you will find this frequently during this demonstration, and we have some sample runs in the data file. So when I'm going to run this, as you can see, a list of meaningful tokens has been generated. This one, yeah. And an environment is also generated for the language. That is, it's a simple calculator algorithm, which is giving you a list of meaningful tokens. And apart from that, let's run another sample run. There's a factorial ProPy file, which gives you the output of a factorial. And as you can see, again, a list of tokens, a meaningful list of tokens is generated. And this list of tokens will be given to the parse tree to generate a parse. It will be given to a parser to generate a parse tree. Now, Piyush will continue. Thank you.
Hi, I'm Piyush and I'll be explaining the parsing section for our language. So our parser will basically check for the syntax of the input, and it will take the streams of token generated by the lexer and it will give out a parse tree which will then pass to the evaluator. Coming to the code, we have this program predicate which will basically generate the parse tree for the entire program, followed by which we have the D predicate that is going to generate parse tree for all the declarations. And here we can have Boolean, integer, string. So here you can declare variables and also assign value to them. Then we have CMD predicate, which will generate parse tree for all the commands. Here we have included while loop, do while loop, for in range. Then we have if else, inside which we have added this elif functionality. So you can create an elif ladder and our program will successfully generate the parse tree for it. We also have ternary operations and we have also added these two extra features for increment and decrement. And the B predicate will generate parse tree for all the Boolean expressions. So we have logical operators such as and or not. Then we have relation operations such as greater than, equal to, less than, equal to. Uh, we also have the exp predicate that will basically generate parse tree for all the arithmetic operations such as addition, multiplication, division, and multiplication. And the last part is the string predicate, number predicate, and alphabet predicate, which will generate parse tree for string, number, and alphabets. And to show a demo of the parse tree generation, I have this sample code. So I'm just going to run this and show the parse tree for it. So this is how the parse tree for any program would look like. Thank you.
Hi, my name is Ashita Jain, and I will be explaining the evaluator rules for our program. So this is our git repo for the program, and in the propy.pl you can see that it is a combination of the parser and the evaluation command. So we'll start with the evaluation command. So first our query will run the eval program predicate, the rule that we can see here. So first we'll go into this. So in our language, we are ending our program by giving out the values of the final environment. So as you can see, after program ends, so we have written the final environment value so that we can know what are the final values of the variables that we have in our code. So it will then go to the eval start. So in eval start, so our language supports declaration plus command and only commands, but it does not support only declarations. So if we have declaration and then followed by commands, it will go into this first rule. And if it only has commands, like we can print a value, so it will, and we can run a for loop, so it will go into second rule. So after start, so we have the declaration rules. So basically we are supporting three declarations, that is in boolean and string, and we are supporting multiple declarations. So we have two rules for each of the type of declaration, like when we are only declaring a variable, so like this first rule. So if we are only declaring the variable, we are taking a default value as 0 for int, false for boolean, and an empty string for the string. And if we are declaring the variable with a value, then we are updating that particular value in our environment. So as you can see, these are the two rules for int, these are the rules for bool, and these are the two rules for string. So after declaration, we have our command. So in our commands, we will have all the kinds of loops like a while loop, do while loop, for loop, and we will have a print statement. We have our ternary statement, assign statements, increment statements, decrement statements. We have all those kinds of things in our command. So to remove the ambiguity in our command and to support multiple commands, we have this particular eval command, and we have eval cmd associated with it, so that if we have only one, it will go directly into those particular command. But if we have more than one commands, then it will evaluate the first command and then it will again go into eval command. So as you can see, so we have different rules for our commands. Like for while loop, you can see. So if the for loops, it will depend on the conditions, how many loops we will have. Like for while loop, it will depend whether the Boolean condition we have is true or false. So if it is false, then it will not do anything. But if it is true, it will evaluate the Boolean condition. If it is true, then it will evaluate the command. And after the command, it will again go into the while loop to check the condition. This is how it will perform the repetitive computation. So this is the while loop. Then we have a do while loop. So in do while loop, we will first evaluate. So in a do while loop, we'll have to first evaluate one command. So it will evaluate the command, then it will check the Boolean value. If it is true, then it will again go to do while. But if it is false, it will go into this particular loop and won't do anything further. It will just evaluate the command for one time. Then we have our for loop, as we can see, we have two kinds of for loop. We have a simple traditional for loop in which we declare a variable, then we have our condition, and then we have the increment operator, or we have our for in range operator. These are the rules for that. Then we have our if else loop. So we have traditional if else, but we have also included elif rules in that. You can have one or multiple else if rules between the else, if, and else. So you can see that here. So we have all the if else rules here, depending on whether we are using only if and else, or if we are using if, elif, and then else. And we have our assign statements. We have assigned for expressions, for strings, and we have our ternary statements, and then we have our print value. So for print, we first evaluate the value of the expression or anything that we want to print. We first need to evaluate it. That's why we have an eval value function, and then we write the value that we receive from that particular function. Then we have our increment and decrement operator. Increment basically is a C++, meaning incrementing the value of the variable by 1 or decrementing the value of the variable by 1. So we have that. So eval value, we have our identifier, we have our strings, we have our booleans, we have our evaluating the boolean expressions. So numbers, these are all come under our eval values. So this is the computation that is for the for commands. Then we have our ternary command. So ternary, it depends on whether the ternary operator is true or false. Then based on that, we'll do the next, evaluate the next expression. Then we have the rules for our elif command. Like if we have multiple elifs, then if one is true and the second one is false, how it will go to perform the repetitive procedure with the help of this particular rule. Then we have our num up, and num up is basically incrementing the values. Then we have all the Boolean rules. So we have equal, we have not equal, we have less than, greater than, less than, equals to, greater than, equals to. We have also included logical Booleans like and, not, and or. So these are all the rules for Boolean expressions. So like for example, we have the rule for not. So if you're receiving a value as false, we'll be returning true. And if you're returning a value true, we'll be returning false. Similarly, we have all the rules for and, like if any of the variable is false, then it will give the false as the answer. So here are all the rules for the eval boolean. Then we have expression if we need to perform arithmetic expressions, and we have our plus, we have our addition, we have our subtraction, and we have multiplication, division. So these are all the rules for eval expression. We will have only number, or we need to look any value, or we need to assign the expression to a variable. So these are the rules for that. Then we have a lookup. So lookup is used to look up the value of a variable in our environment. It will basically take the variable name as input and will give the value which is present in the environment as output. Then we have our update. So in update, it will update the value of a variable in the environment and give the new environment as the output. And lastly, we have remove. So remove will remove that particular variable from the environment. So these are all the evaluation rules that we have for our language. Thank you.
Hello readers, my name is Vinita Maru and I'll be walking you through the GitHub repository and execution of the project. Let me get you started with that. Once you go to our GitHub repository, 59, you can clone our project from here. Once you have cloned the project, you will need to first install the PySwift library. This library helps to execute Prolog queries right inside from Python. Since we are using Lexer in Lexer written in Python, we will need to execute the Prolog query from Python itself. If you see on the left side of the window, you'll see the structure of our project. In the data, we have all the sample codes of our project, which you can run to see the output. In the docs, we have our contribution.txt, and in the source folder, we have our Lexer and our parser and evaluator stored in propy.pl file. If we in the Lexer, it will take input as one of the source files, and it will provide a token stream of the source program. With the source program, with the tokenized source program, we execute the Prolog query with the help of PySwift library, just like this. And at the end, we see the result if the compilation is successful or not, and also the parse tree and the output as presented by the program. Now I'll walk you through how to run the program. Okay. So since we are used to Python Lexer, I'll be using Python to run the Lexer. I'm using the calculator program. Let me show you the program first. This is just a simple program. Here we have written programs to add, subtract, multiply, divide, and get the power of numbers. So I'll run this program here. And as you can see, after running the program, first we will get the tokenized stream of the source program, and after that we will get the result of adding, subtraction, multiplication, division, power, and at the end we will also see the final environment. Also it says if the compilation is successful, and also we have the parse tree. I'll also show one more source program. Let's see the code for do while. So in do while loop, we are just incrementing z and decrementing x as long as x is not equal to 0, and at the end we are just printing the value of z and x. So I'll show you this program. So the value of z at the end of the loop, do while loop is 2 and x is 0. Also the final number shows the same. Also you can see the tree for this program. The same way you can run all other programs as well. Thank you so much.